Okay, we've got a fun problem today. Add two numbers. You're given two linked lists and you're expected to add them. The trick or the catch is you're adding them from left to right instead of right to left like we traditionally do in addition. So just to give you an example, here we've got these two linked lists. We're going to first add 2 plus 5 equals 7, and then 4 plus 6 equals 10. Notice how the current value is a 0, and then you don't see it here, but they're carrying the 1 over here. So now it's 1 plus 3 plus 4, and that equals 8. So the trick is we're going to have to worry about this remainder value. So what I'm going to do first for the problem is just say remainder equals 0. Sometimes the linked lists are of different length, and also sometimes when you add them together, there's going to be a remainder value, even though you've traversed both linked lists. So I need to make a while loop, and I'm going to say while list 1 exists or is truthy, or list 2 exists or is truthy, or remainder exists. And this is going to ensure that when we're going to traverse these linked lists no matter what, as long as one of these values is truthy, okay? So I also need to make a sum and keep track of the current sum because we're going to create a new node that encapsulates these additions. So 2 plus 5 equals 7. I'm going to create a new node that is equal to 7. And then 4 plus 6 is equal to 10. I'm going to make a new node. I'm going to set its value to 0. And then I'm going to have that remainder carry over and so on. Okay, so let's make the sum right here. So let sum equals 0. And inside of my while loop, I'm going to check if we have an L1 value. I'm going to add that to my sum. Then I will traverse that L1 list by saying L1 equals L1.next. I'll do the same thing for L2. L2 equals L2.next. So now we are capturing the sum of each of these values. And actually, I want to put the sum inside the while loop, right? Because every while loop that fires, it's going to need to calculate a new sum. So let's say sum equals 0 right here. And remember, if we are to add like two values, let's say 4 plus 7 equals 11. We're going to have the current value is going to be 1. And then also the remainder would be 1, right? Likewise, if I did 4 plus 6 equals 10, the current value, as we showed right here, would be 0, and then the remainder would be 1. So that's the pattern we need to follow. With that said, we need to add our remainder to our current node. We're initializing remainder as 0 because when we first start adding the linked list together, obviously there's no remainder. But from then on, we can just say sum plus equals remainder. So we're keeping that remainder accounted for. Okay, so progressing on here, we're doing exactly what we need to do. We need to now create a new linked list, which is going to be our result that we're going to return for our answer. So I'm going to make a variable called dummy, and I'll say new list node. Initially, I'll set the value to 99 with a next pointer of null. And I need a way to traverse the dummy linked list, which is going to be our answer. This is because right now dummy points to this 99 node, and I don't want to lose that pointer to that start of the list. So I'm going to make another variable called tail and initialize it to dummy. So now I can traverse tail, and then I can return the dummy at the end of the problem, and that's where my answer starts. Okay, so going through this, so far we're dealing with our remainder. That looks good. Let's create our node that we're going to add, which is just going to be the sum. So I'll say let node equal new list node. And I'll pass in our sum with the next pointer of null. Now, recall when our sum is something greater than 10, greater than or equal to 10, so like 4 plus 6 equals 10, just like this example here, we actually don't want to put 10 as the value of our node. We want to put 0. Likewise, if we did 4 plus 7 equals 11, we don't want to put 11 as our sum. We want to put 1. So the way we can do this is by using the modulo operator with 10. And basically, we're going to reduce the value of sum by 10 until we can no longer do it anymore. So in this instance, it would just give us a value of 1 for our node. Then we need to update our remainder, right? Because now we have a remainder value. So you would say something like remainder equals sum, and we're not going to use the modulo operator. We're going to use division, because like imagine if we have a sum of 20, we know the remainder is going to be 2. So we need to say divided by 10 equals 2. But what happens if we were to do 22 is our sum, and then we divide that by 2? Or divide that by 10 rather. It's going to be some fraction like 2 point something something something. Because of that, we need to floor this value using math.floor to ensure that our remainder is always a whole number. So now that we've got that logic in place, we can attach our newly created node to our linked list of dummy. So I'm going to do that by using tail.next equals this node we just created. And now I'm going to traverse the tail to the next node in the list by saying tail equals tail.next. So if I return or console.logout our dummy, let's see what happens. You can see we're returning that 708. So that looks good. And we can just get rid of this 99 very easily by saying dummy equals dummy.next. That's going to push our pointer 1 over. So we can just return dummy now. And there you have it. There's our answer. The time complexity of this problem is O of n. This is because the number of operations we're performing is directly proportional to the amount of inputs. We are looping over each list n amount of times. Also, the space complexity is 2 O of n because we're having to create the same amount of nodes per input. Okay, guys, I hope you enjoyed this problem. If you did, make sure to like and subscribe, and I will see you in the next one.